we present the stress-strain relationship for isotropic materials. Isotropic materials are those materials which have constant properties in all three directions x, y, and z. So this is a relationship between stress and strain. Please note down this equation where D is called stress strain matrix or constitutive matrix. D is stress strain matrix or constitutive matrix, where E is modulus of elasticity and V is Poisson's ratio. We have already defined sigma and epsilon. Sigma matrix has three elements: sigma x, sigma y, and tau xy. Similarly, epsilon matrix has three elements: epsilon x, epsilon y, and gamma xy. So this is the D matrix when sigma z is not 0. Okay, now note down this equation for the condition where sigma z is not 0 but tau xz and tau yz are equal to 0. So in this scenario where sigma z is not 0, we'll use this equation for D. Now we will derive the stiffness matrix for triangular element. So now in this section we will derive the stiffness matrix for triangular element. So consider a plate. This is a plate which is subjected to load Ts. The first step is to discretize the plate into small elements. So you can see in this figure that it has been discretized into triangular elements, and we have selected one triangular element which has three nodes I, J, and M. 2D element has three nodes I, J, and M, and each node has 2 degrees of freedom. That means it can move in x. Each node can move in x or y. So x displacement is represented by u and y displacement is represented by, first note down this equation 6.2.9. This is the formula that is used for calculation of uh, area of this triangular element. So we can find the area of triangular element by using this equation 6.2.9. Then note down the equation 6.2.10. Note down these alphas: alpha I, alpha j, alpha m, beta I, beta j, beta m, then gamma I, gamma j, gamma m. In this equation you can see here that beta I, gamma I, beta I, these are the values that were calculated in the previous equation, which was 6.2.10. Those values will be used here Bj and Bm matrices. After noting this equation 6.2.32, you will note down the equation 6.2.34 and 6.2.33. These two equations, you will note down these two equations. This is the stiffness matrix for triangular element, where T is the thickness, A is area of the triangle, B is the B matrix that you have seen. T stands for transpose, D is stress strain relationship, and B is the constant matrix that you have already defined before.